Okay, we continue from last time, right? We calculate the AC circuit using phasor analysis. Okay, AC circuit we consider only steady state condition. Steady state. It means nothing changed. In fact, it's changed all the time because the AC voltage and current is changed according to sinusoidal signal, right? It's sinusoid signal. It's changed all the time. Okay, but we consider steady state. It means nothing changed. It means only the signal is AC. Okay. So what do we do? So we change the voltage in this form, right? We make cos omega t plus theta v. Omega is 2 pi f, right? Angular velocity. We write down in the form of phasor of voltage is V max divided by square root 2 angle theta v, right? And for the current also. For the current in the form of I max cos omega t plus theta I in form of phasor of current is I max divided by square root 2. This is what is this value? What is this value? Last time we talked about this value. The peak value divided by square root 2. What is this value? RMS value, right? Very good. Root means square, right? This is RMS value. Okay, so when we talk about AC circuit, usually we use RMS value. Okay, like 220 volt in your home is the RMS value of voltage. Okay, 220 volt in this room also, right? This means RMS value. And the current also 10 ampere. What's mean by 10 ampere is RMS value of the current also. Okay, and with the phase angle of theta I like this. So we calculate in terms of absolute and angle, right? Okay, and then for the resistive load, R is just R, right? And for the inductive load, L, XL, JXL is J omega L, right? Omega is 2 pi F. And for the capacitive load, JXC is 1 by J omega C, right? And we can form in terms of impedance is R plus JX, right? Like this. Okay. X can be both XL or XC, right? Okay, so all value is transformed into complex number, okay, right? Complex number. Then we calculate in terms of complex number. We can use Ohm laws, like V equal to I into impedance, right? This is complex number and the complex number, okay, right? And the output is the complex number. We can calculate every value in complex term. We can also calculate complex power in form of VI conjugate, right? This is complex number. This is complex number, or we can consider it as a vector value, right? It's like a vector value with the real axis and imaginary axis, right? Real and imaginary. And the power in AC circuit also have real and imaginary part, right? It is a complex value. So the output is real and imaginary part, right? And we call real part as real power. P is real power. And Q is reactive power, right? Power. So we can have all value in complex term. And we can also calculate power factor, which is the index represent the ratio between real and complex power, P and absolute S, right? This is in complex term. The complex power can be write down like this. P, Q, and S, right? Last time we come around here, right? This is just summary. Okay. So when we face the AC circuit, we just write down voltage and current. In phasor form, we transform all impedance, right? Resistance and inductance and conductance in terms of impedance. Just after that, we can calculate, right? Okay. So may I delete my writing now? Okay, you can follow, right? You can follow. I delete my writing here. Okay. Let's see this example, right? This example, we have voltage supplied to resistance and inductance. In this case, the inductance will transform into J omega L, right? And the resistance is just the resistance. And for the voltage, we transform into V max divided by square root 2 and move theta V, right? Okay. So we consider cosine as reference, right? Omega t, V max cosine plus theta V, right? V is this function is for cosine as reference, right? In this case, the voltage is in this form, right? V is 14.14 sine omega t is mean that is 14.14 cos omega t minus 90 degree, right? Okay, here, right? So V would be 14.14 divided by square root 2 with the angle of minus 90 degree, right? So this is 10 minus 90 degree, right? Here. Or 10 with the angle of minus pi divided by 2 radian, right? It's the same value, right? Okay. Then for the inductance J omega L, XL, JXL would be J2 pi. What is the omega? Omega is here, right? 377, right? This is omega. This is 2 pi F. So 377 J omega L. L is 8 millihenry, right? 8 millihenry, like this. So we get J3. So this is the impedance, right? So in this case, is this circuit we transform into phasor form. This is the voltage and impedance like this, and the voltage is 10 minus 90 degree, and the impedance is 4 plus J3, right? Because the resistance is 4 ohm. Or it is 5 with the angle of how much for this angle, right? 4 plus J3. What is this angle? It's 10 inverse of T by 4, right? T by 4. And this is 10 inverse. Is 36.8, right? 36.87 degree, right? Or is it 0.644 radian, right? Oh, sorry, 5. Or 5, 0.644 radian. Okay, are you following? Okay. Then you can calculate current. Current is just the voltage divided by impedance, right? Current is V divided by impedance. You use this value divided by this value, right? You can obtain the current in phasor form. Okay. The current in phasor form here. But in this example, the calculation is in radian system, right? When represent the angle, right? The angle of the vector is in the radian unit. Is in radian. Okay, just be careful with your calculator, right? When you calculate. Okay, then we get the current at 2 and the radian of minus 2.215 radian, right? Or is equal to 2. What is the degree in angle? 2.215. What is the degree in angle? How to get the degree in angle? We multiply with 180 and divided by pi value is okay, right? Multiply 180 divided by pi is 1, 2, 6.9 degree. Can you transform minus 2.215 radian is minus 126.9 degree. Can you do this? Can you do this? Okay. Anybody have some question about this? You can do it. Okay. And it also mean that the current, this is in phasor form. In fact, the signal of current, what is the signal of current? The signal of current is, in fact, I is square root 2 into 2, right? This is the peak value. Cos omega is 73773, then, and this angle, right? Minus 2.215. If in case of gradient, or is square root 2 and 2 cos 377 t minus 1 to 6.9 degree, right? This is the actual current flow, right? But we don't need to calculate in terms of uh, sinusoid function, sine or cos function. Okay. Okay. I think until now it's okay. Come to this point is current. We calculate current, right? Now we get the voltage and current now. Okay. Then this is voltage, right? And this is current. This is voltage. Okay. And we can calculate and the current. What is in fact the current is 2 and 126.91. Right? Okay. Right now we have voltage is 10 minus pi minus 90 degree, right? And the current 2 minus 126.91 degree, right? If we calculate complex power, S is VI conjugate. This is 10 minus 90 degree. And then 2 minus 126.91 conjugate. What we get is 10 into 2 is 20, right? And the conjugate will change this to positive value. What is the final result of the angle? This is 36.91 degree. Okay, because of this conjugate, right? Right, it's become positive. Then here is the result, and the unit of complex power is in VA. This is a unit of complex power. Or we can write down in terms of P and Q. So P and Q. So it would be 20 into cos 36.91 plus J sine 36.91, right? And this is cosine multiplied 20 is 16 plus J is 12 VA. Okay, this is so we have real power of 16 and reactive power of 12, right? And our real power P is 16 watt and Q is 12 watt. Then it's the same result with this method, right? This method just calculate real power from VI, and cos of the theta here, right? But we can use this general form, right? We just calculate VI conjugate, okay? V and I conjugate. We get the same result. With this method, maybe it's maybe easier to get some systematic, right? Calculate, okay, for calculation, for your calculation. Just calculate total complex power from VI conjugate, right? You can get real power and reactive power, right? And what is the power factor? In this case, V is P plus JQ. This is, S is P plus JQ. This is 16, this is 12, this is 20, right? Yeah. This is square root 16 square plus 12 square, right? Yeah. Okay, this is P and this is Q, right? What is power factor? This angle is 36.91. And what is power factor? Power factor would be 16 by 20. And it is 0.8, right? It's the power factor. So if the question asks about the power factor of this circuit, the answer is 0.8, right? Power factor is 0.8. Power factor is the ratio between real and complex power. Okay, S is complex power, right? We can call complex power, or we can call this value apparent power. Complex or apparent power. Okay. This is the total ampere power, right? But it's the real and reactive power. Okay, any question about this example? Okay. And this is the complex power calculation. Okay, we have what is the figure? No figure here. Okay, anyway, from voltage and current, right? From voltage and current, we calculate complex power, right? And the voltage is V is 100, right? 100 divided by 2 and with the angle of 0.262 radian right here. If we write down voltage in terms of phasor, right? And what is the angle in terms of root 2? 100 divided by square root 2. And then here is 100 divided by square root 2. And what is the angle in terms of degree? 0.262 divided by pi. And it's just 15.01 degree, right? And then for the current would be 2 divided by square root 2 minus 0.262, right? And it is 2 square root 2 minus 15.011 degree, right? And this is the radian term. Okay? Are you following? Just transform sinusoid function into phasor, right? The voltage is P divided by square root 2, right? And this angle, similarly for current, right? Then what is the complex power? Also, sorry. This is current, okay? This is current, right? And What is the complex power? It is V into I conjugate, right? It should be 100 by square root 2. So it depends on which system you convenient, right? Okay. So I use 15.011 degree, right? Into 2 by square root 2 minus 15.011 degree. Conjugate, right? What is the total? It's 200 divided by 2 is become 100. Its angle of this is become positive, and then it's 30 to degree, right? How we can calculate in terms of radian? What is the radian here? It should be 0.262, 0.262. We should be 5 to 0.5 radian. Okay, this is 0 here. And then we can also write down in terms of P and Q, right? P and Q. What is this value in terms of complex? Right? In complex term. In complex term, it will be 100. And then cos 30.022 plus J sine 30.022, right? Okay, because this is a complex value, right? And it consists of P and Q, and this is S, right? It's P plus JQ, right? Then what is this value? It will come out of 36.6 plus J50, right? And this is P and this is Q, right? Then is according to this value and this value, right? P is 86.6 watt and Q is 50 watt, right? It is the complex power. This is the method of calculate the power in AC circuit, right? Okay. Usually in AC system we interested in the power usage, right? The power used in the building, in the room, in the house, for example. Okay, and we have two parts of power in AC system, right? Real and reactive power. Okay. Okay, any question? According single phase. Okay. So I continue three-phase circuit, right? Okay. In power electrical system, we use a lot of power. It's high power. We usually use the electricity in three-phase system. So three-phase system, we have three single-phase system connected to each other and is shifted by 120 degree, right? It's shifted by 120 degree. Okay, and we will have three phase A, phase B, phase C. In fact, phase A come and then phase B will follow by shift by 180 degree, and then phase C then 120 degree, right? Okay, and in phasor form, if we use phase A as reference, phase B will lag by 120 degree, or the phasor of phase B will lag phase A by 120 degree, and phase C is also shift another 120 degree, or plus 120 degree, phase B and phase C, right? And Usually we generate the electricity from the generator, three-phase generator. Okay, we have three-phase generator. And when we say the voltage in three-phase, it usually means the voltage between phase A and B, or B to C, or C to A, or we can call V from line to line. And we have the reference node we call neutral, right? Neutral node here. And the voltage between phase A and neutral we call V phase here, right? And the voltage between A and B is equal to V from line to line is the square root T into V of the phase. Okay. The voltage between the line is equal to square root T into the voltage between phase, right? And in fact, it's shifted by 30 degrees also. Shifted by 30 degrees. This is the voltage between phase. So it shifts by 30 degrees like this. The voltage between phases. Phase to phase or line to line here. Okay. So in the power generation, usually we send the power in three phase. Okay. You can see in the transmission system is usually have three phase, but when we use electricity in-house or in the building, we have single phase equipment, right? Single phase, we have only two lines, right? It's line and neutral together. And in the large industrial load, is use three phase. Is use three phase. So when we generate from generator, we will have three phase, and then we send the power in three phase, right? And in this three phase, we will have neutral line in when it's neutral when it's close to the user. We have phase A, phase B, phase C. Some equipment will use three phase, like motor. Some equipment will use only two phase, only one single phase load, like a lamp, right, or your household use. So the voltage between phase to phase or line to line, we call line to line, and from line to neutral is different value, right? The voltage from line to neutral is the voltage of line to line divided by square root 3. For example, in Thailand, the low voltage, we reference the voltage between line to line in Thailand. The voltage between line to line for three-phase system is 380 volt, and it results in the voltage line to neutral is 380 volt divided by square root 3 is 220 volt. Okay. In fact, this building we have three-phase system. Okay, and then like we have three-phase system A, B, C, and N. A, B, C, and N like this. Okay, and A, B, C. We feed the electricity. We have four lines, okay, in this building. And for the elevator, for example, for elevator, the motor will use three phase. If we supply the power to large motor, like a chiller or elevator. This building we have one elevator, right? Elevator. To use three-phase motor. And when the power come to this loom, is fed from single phase, right? This is 380 volt and it is 220 volt. Just to use in this loom, for example. Maybe to another loom, they just pick up different phase to another room, to another floor. And maybe they pick up the different phase to another area for single phase, right? Okay. So you can see the switch panel, right? The breaker panel, right? It have three phase, the switch of single phase. Okay. And the designer will design the system to balance every phase, to equal use of every phase. We try to use phase A, phase B, and phase C in equal condition, right? As possible. Okay. Okay, you get some idea, right, about three-phase system, right? Okay, so in three-phase system, the voltage is higher than single-phase system because we use line-to-line voltage, right? Line-to-line voltage. Okay. Then this is the phasor form of three-phase system. This is line to neutral. Phase A to neutral is, for example, if this is 120 volt, from line to line will be here, right? Between A and B. A and B will be 220 volt. This is 380 volt, right? Okay, and it's chip phase also, right? It's phase chip also. This is in terms of sinusoid function, right? This Vmax 2 pi f, this Vmax plus 120 and minus, this should be minus 120 and minus 240, right? Okay, so in balance T-phase load, like for example, this is the motor. If this is the motor, we supply T-phase to this motor. The voltage between phase A and B and C is V. This is voltage from line to line, and the current from one line is here, right? The power into this balance T-phase can be calculated as square root 3 V line to line plus I line. It comes from V. The power of phase A is VANI line. Phase B is VBNIA, right? And IB. Phase C is VCNIC. We plus together, and if current are the same and the voltage are also V equal to VAN is square root 3 is square root, VAN is V line divided by square root 3 and I line, right? Three values are equal, right? Equal to SB equal to SC. So this is 3 multiplied into this value. Total power would be 3 times of VL divided by root 3 IL. And square root 3 and 3 becomes square root 3, right? 3 divided by square root 3 is square root 3 here, right? Okay. So this is the power in three-phase system. And real power is square root 3 VI and cos theta, right? It's the real part, right? Q is S sine theta, right? Q here. So it depends on the phase shift between V and I also. So just similar to what we have done in single phase, but in this case, we will have square root 3 here, right? Square root 3 here for three-phase system. Okay, let's see this example. For three-phase AC motor with the terminal voltage of 380 volt, it draws the current by 50 amp and the power is 285 kilowatt. Can we compute the motor apparent power and the power factor? Apparent power means S. Can we calculate S right here? We know voltage and we know current, but we know only absolute V and absolute I. We don't know the angle of between voltage and current right here. Okay, so in this case we can calculate total apparent power or complex power, right? Complex power or apparent power. Apparent power is square root 3 V and I. V is 380 and I is 50 amp. So total is 32908 VA or 329 kV kilo VA, right? Kilo VA. And P, we measure the real power. This is mean P, right? Is 285 here. And S is P plus JQ. We know that S equal to P plus JQ, right? And at this moment, we know that S is 329.09 kVA and P is 285 kW here, right? At this moment, S is here and P is here. We can calculate what is Q. Can we calculate Q from this triangle? Can we? We can calculate Q from S square minus P square square root, right? Pythagoras. Okay, this is one method. You can calculate. You can get this angle, right? You know P, you know S, you can get the angle, right? You can use trigonometric for Q, right? Or you can calculate power factor. Power factor is the ratio between P and S, right? P and S, which is 285 divided by 329, right? It's 0.866 is power factor, which is also you need to calculate, okay? So in this case, we calculate apparent power and we calculate power factor, right? Okay, and if the question asks about reactive power, we can also calculate reactive power, right? Okay, but in this case, the question doesn't ask about the reactive power, right? Okay, so if I ask about reactive power, I think you can calculate, right? Okay. Then let's see another example, right? Compute the apparent power, reactive power, power factor of the three-phase AC balance. The voltage is 380 volt, current is 100 ampere. The real power is 400 kilowatt, right? So apparent power is square root 3 V and I, right? V and I. So we calculate apparent power at 658.18 kVA, right? Here. And we know that real power is 400. Now we know that S is 658.18, right? And P is 400, right? Kilowatt kVA. So how much for Q is okay. You can calculate Q with this value. You can calculate power factor is P divided by Q. So it means that the apparent power is in this form, right? And its magnitude is 658.18. On the other hand, you can calculate this theta, right? What is this theta? You know that cos theta is 400 divided by 658.18, right? Okay. Then you can get theta as the cos inverse of this value, right? Right? And also that after you know theta, another way to calculate Q is P tan theta, right? Q is P tan theta, right? Because Q by P is tan theta, right? Q divided by P is tan theta. Okay? So many methods. So you get, if you calculate Q from this method, you must get the same value, right? It should be the same value, right? Otherwise something wrong, right? Because it comes from the same triangle, right? Okay. Okay, this is your homework, right? Okay, and this is also your homework. But this in this problem, the information you have is power factor. You know P divided by absolute S. Okay, you know power factor instead of knowing P, right? Okay, you know this value instead. I think you can do it, right? And it's good to do this homework, right? Okay, I will break here. Okay. Any question? No.